Hi, I'm BJ Higgins from Michigan State University, and the title of my lightning talk is Stated Skein Algebras for Kuperberg Webs. I'd like to thank the Tech Topology conference organizers for allowing me to give this lightning talk. So I'd like to give the definition of skein algebras of surfaces. So let sigma be a compact oriented smooth surface and consider linear combinations of links in the thickened surface. And we will impose some skein relations on those links coming from a quantum group G. And the product for the skein algebra will be defined by superposition. So here we have a link in a thickened torus, and here we have another link in a thickened torus, and the product of these two will be defined by the two links where the first one is drawn on top of the other one. And in the case that our quantum group is quantum SL2, then our skein relations are the Kaufman bracket skein relations. So in general, these skein algebras these are algebras and they're infinite dimensional in general and non-commutative. So the algebra structure is hard to study directly. So to get a handle on the algebra structure, we'll use some machinery that was introduced by Tong Lei called the stated skein algebra. And the idea of the stated skein algebra is to have the algebra structure be compatible with cutting the surface. So, we'll allow our surface to have interior punctures and also boundary components that have punctures. And we'll think about cutting the surface along an ideal arc whose endpoints are punctures. So the idea is that we'll have a splitting map, which is an algebra map from the skein algebra of a surface to the skein algebra of a surface that's been cut along an ideal arc. And there is an explicit state sum definition that you can write down, and you have to impose skein relations along the boundary called stated skein relations, and you have to let your links be allowed to actually be tangles that have states that are on the boundary of the surface. And one thing nice about this machinery is that the stated skein algebra of small surfaces, like a disk with a point removed from the boundary, is just the ground ring. The skein algebra of a disk with 2 points removed is the quantum group that's associated with the skein relations that define the skein algebra originally. And this skein algebra of the triangle is also one that has an explicit presentation. And these are known for SL2, SL3, SP4, and SLN. Right. And so to study the splitting maps and prove things about them, we want bases for the skein algebras. And Shakur and Westbury developed a method of constructing bases in certain cases. And that's where when the list of skein relations is terminal and confluent. And that means that if your skein relations are of a form where each skein relation simplifies, so it writes a complicated picture as a linear combination of simpler pictures, then you'll have a terminal list, and that will mean that your reducible diagrams span your skein algebra. And confluent is what you need to have your irreducible diagrams be linearly independent. And so here are explicit skein relations for that Kuperberg described for SL3 and SP4. And so they're strictly simplifying. You can get rid of crossings, and then you can further simplify using these other relations. And same thing with SP4. But there are cases where the skein relations overlap. So here there's a square removal relation. There's also a diagon removal relation. And if they overlap, you have to check that applying one before the other gives you the same answer as applying in the other order. And Shakur and Westbury checked that they are confluent. And in my work, I sort of extend that idea to the stated skein algebras and show that the stated skein algebras admit terminal and confluent relations, which give bases which extend those of Shakur and Westbury. And as a consequence, you can show that the splitting maps are injective, and we can describe their images. And it allows you to split the surfaces into smaller pieces and use the quantum group to study the skein algebras of the small pieces. And we can also recover the fact that Kuiperberg's web category describes a full subcategory of OQT comodules. Okay, so thank you for your attention.